the College of St. Scholastica and direct our National Center for Computer Science Education. And I'm here with two of my awesome co-conspirators at Hermantown Public Schools. Liesa, do you want to say hi? And then Edyn?
Hi, I'm Liesa, and I teach middle school STEAM, which is computer science and engineering at Hermantown Middle School.
Hi, I'm Edyn. I teach math and then an intro CS course for 9th and 10th graders in the high school.
Great. So we're going to talk to you today about this idea of building the plane while we're flying it. How do you create computer science STEAM pathways at schools, and then try to think about that pathway and what students are learning along the way. Let's start first with some introductions. We'll do a Jamboard here, and I will drop that link in the chat for everyone. So on the first frame of the Jamboard, you should see the prompt there. Add a post-it with your name and the age you wish you could be right now. If this is the first time you're using Jamboards, over on the left-hand side, you should see right below the arrow pointer, there's a sticky note tool, and you can open that up. And I'm going to say, add my name and 10 years old. Actually, I should ask first, what age are fifth graders? Is it 10, 11?
10 to 11.
That's it. Fifth grade was a good year for me. That's what I want to be back in, fifth grade. So.
And we are going to be toggling back and forth with this Jamboard periodically, so good to keep it close, or I'm actually going to split screen. So I've got my Zoom on one half and my Jamboard on the other.
All right, so Liesa, 9 years old, Edyn, 17, Nathan, 40. Nathan must be at a good age right now and loving it, huh? Jessica, 32, Jim, 11 years old. Thank you for sharing and giving that quick introduction with us. Our session today, and I'm going to go into slideshow mode here. Our goals or objectives are that you will be able to identify resources for middle and high school STEAM curriculum, make connections between computer science and other subject areas, including to the new computer science benchmarks that are coming out in Minnesota state standards, be able to scaffold computational thinking practices and concepts across middle and high school courses, and then use computer science in classrooms as a strategy for student-driven differentiation. So the continuing ed strand is around that idea of differentiation and accommodations for students. So we'll start with some quick definitions. These come from a presentation that the Minnesota Department of Ed gave. If you were in my earlier presentation today, you probably saw these next couple of slides. So hopefully it's just a refresher, but for those of you who are new, computer science is a term you might have heard before. A more formal definition for what computer science is the idea that we're studying computers, their algorithmic processes, including the principles of computer science, hardware and software, how that gets implemented, and then their impact on society. So what does it mean to be using all of that technology, and how does it change the world we live in? Computational thinking is another term you might have heard, and that really is a broader term and can encompass other disciplines and makes a lot of connections across subjects. So it's a set of problem-solving skills and a process that is central to computer science. And then the thing probably people think of most often when they think of computer science is this idea of learning to code or learning to program, but that's just one of a specific set of technical skills within computer science. So just laying the groundwork there by what we mean by those three things. The Minnesota Department of Education is integrating computer science as they update each of these subject area standards. Their motivation for doing that is this idea that the world is increasingly relying on computer science and computing technologies, and they want students to be able to understand how it shapes and influences our daily lives and our work. Also how it can power and generate innovations in many different areas. So many scientific innovations these days are driven by the power of computing. you think about science and citizen science data and being able to, collect moose sightings and all of that, that is the power of computer science, allowing us to be able to gather much larger data sets and look at trends in that way. Computing also is an equity issue in that we want all students to be able to have access to computer science jobs if they find themselves interested in that. And then in terms of rolling out the new standards, the timeline is in the blue box there. The first ones that have been done are the arts and science ones. Arts roll out next fall. I should say that in the fall of 2023. So not this upcoming fall, but the fall after that. And then science, and then English language arts and social studies, and mathematics is actually still in the draft process. But if you've looked at the draft of the math standards, there's a ton of computer science in them. I'll just share with you a couple of these benchmarks so you can get an idea of what this looks like. So here's an example of a benchmark for kindergartners in life science that includes a connection to computer science and computational thinking. So the standard is students will be able to represent observations in data in order to recognize patterns in the data, the meaning of those patterns, and possible relationships between variables. So one of those other key technical skills about computer science is data analysis, and being able to collect data and think about different ways to analyze it is a key part of computer science. And so this benchmark standard is a good way to get kindergartners started in just thinking about data and collecting it and looking for simple patterns in it. Here's two other ones, very much in the 4th grade visual arts here, thinking about creativity and how can that be applied and how might people be creative in computing mediums. So maybe it's digital audio and video and sound design and things along those lines. And then in 3rd grade, this idea of in English language arts, about thinking about digital content and how you might express yourself and create works that are digital. So just some examples to give you an idea of what's coming down the line. I also wanted to go over briefly this idea of universal design for learning, UDL. You might have heard of that before, but just a quick overview, and then I'll make some connections to how that shows up in computer science before we dive into Liesa and Edyn sharing about their programs. So in the UDL framework, they talk about engagement, or the why of learning, and really, like that student motivation and connecting to the why, the representation, or the what of learning, and then finally the action and expression, or how students are learning. They have 3 kind of categories for each of those, like how are you creating access for students to access that learning opportunity, building skills in that area, and then internalizing those processes. So there's some examples there under engagement, the why part of it. How are you recruiting their interest and getting them access to the content that way? And then how are you helping them build their skills in persistence and keeping after the task and going after it. And then the internalized part is that next level where they're able to self-regulate and monitor that process themselves and understand when they might be getting disengaged and strategies for how they might re-engage in the activity. All right. If you want to learn more about UDL, if that's a new concept, the link is on the bottom and you can dive more into it. Here's some examples of how this could play out in computer science classrooms. So under that recruiting interest part, one thing that I think is awesome about computer science, and we saw this in terms of some of the MD motivations, is that it's easy to make connections to other disciplines. You're often creating projects that have an application in mathematics, in science, in English, in arts, that kind of thing. And so, being able to allow the students to make those connections to other disciplines is very helpful. There's also a lot of flexibility in giving students choices in projects. And there are lots of options for pacing and support because there are a fair amount of curricula out there with videos, guided tutorials, all kinds of supports around them that students can use to help them pace. There's, in terms of sustaining effort and persistence, a lot of opportunities to provide supports and extensions, like here's an extra challenge that you can add to your project. Why don't you try to make it have a score counter for your game? If you've got the game, characters moving around, let's add one more feature to it. The self-regulation area, being able to have students self-assess and think about process pieces, so not just the content, but also the process. And in computer science, I think one of the defining hallmark characteristics is it never works the first time you build it. And so it's all about trying again and learning to deal with that failure and the problem solving process and really developing those skills. So I will turn it over to Liesa now, and hopefully they'll hit on some of those areas about how UDL shows up in their classes as we go through.
Thanks, Jen. So I've put together just a little bit of kind of overview of what STEAM looks like as a class at Hermantown Middle School. And we've just turned on the 3D printer here, so apologize for background noise. We do focus a lot on process, and that hits it hits at that sort of understanding or universal design for learning, in that we really focus on what the kids are doing minute to minute, as opposed to what they produce at the end of the project. That allows them to take bigger risks, that allows them to maybe get halfway through a project sequence and decide to take a complete pivot to the left, or scratch everything they were working on and try something new. The other thing that we focus on, in addition to sort of process, is this idea of open-ended projects. I'll give them a place to start a prompt and then expect them to kind of keep moving their own idea along. And that really hits at the recruiting interest. They're making their own decisions about what to do with their project. It's coming entirely from their brain. I'm just giving them a place to start. In addition to sort of process and student choice, we really focus on hands-on building, using materials. Lo-fi prototyping is something we do a lot in our class, where they're taking their ideas that are in their heads and they're bringing them into 3D, but they're using materials like cereal box cardboard and pipe cleaners and some tape and string and producing the jet powered car that they imagined or something. I'm gonna skip ahead to the next slide and show you a little bit of an example, or a little example of what one project looked like. So this was a project that our students worked on this year. The prompt was design wearable technology for extraordinary clients. The students were given 19 different clients to choose from. You're seeing 4 of them down below, a mer person, a time traveler, an astronaut, and an evil genius. There was also a robot and a spy and a fairy. Like, there was just all kinds of pictures of characters. And then the students were prompted through a process of creating a backstory for the character, as well as identifying problems and needs that their character had. And so they were creating these things themselves from the images they were given. And then they were asked to design a wearable technology solution that would fit the lifestyle of their character and also solve the problem. From there, they were then given an Adafruit Circuit Playground Express and lots of time to build and tinker. So I've got a 1-minute video to show you what one student made. And I apologize if you can't read. She doesn't use her voice here. She chose to type to tell you all about it. So go ahead and play it and you can see what she made. And I'll just sort of narrate in case you can't quite tell what she's showing you. So she was designing for the time traveler. She identified that the time traveler, whose name is Topaz, was always losing her things on her trips. So she invented this little thing. It's a watch that also holds the artifacts for Topaz. So she's using her own creativity. There's the front of the device comes off and you can put things in it. She's programmed that little device on the top. It's an Adafruit Circuit Playground Express. And so she had to use Microsoft MakeCode to program the device. And then the rest of the device is assembled with sort of lo-fi prototyping materials. We had some fabric, some foam, some clear plastic packaging. So that's just a quick sample of what was made in our STEAM class this year.
Okay, I think, Liesa, do you have everything that you wanted to include in there?
Oh, never, but I would talk for another hour. So I'm just gonna shut up now.
Okay, sounds good. So we'll move on to the high school exploring, kind of give it a new title this year, a new course name, Exploring Data and Computing, and looking at both those aspects. And this is initially kind of a targeted for 9th and 10th graders as kind of an intro CS course, and then they could take an AP class or that higher level CS course later in the high school. But this course really focuses on a lot of problem solving, and that's kind of what we do the first couple weeks. We don't even touch code. We don't even really use that many devices that much, but really thinking about problem solving and approaching problems and how they can work through that. So building on a lot of STEAM ideas from Liesa's class and solving problems and making solutions. But then once we get into a lot of the units, we do look at some UDL concept or try to integrate them in. And really that choice with units is something that I'm trying to kind of increase, specifically with our data unit. We had, or I tried to provide like multiple data sets that they could work with. So ones that they might be interested in, ones that maybe had a little bit less information. So if they had like a really large data set, they weren't getting overwhelmed by it, and kind of giving them the choice with that. And then they could build from there. So even if they use one of the simpler data sets, they could kind of extend from there. So tying in those UDL aspects. And then overall, a lot of time to work on these projects. And on the next slide, I'll show you some of those sample works from the class. But yeah, so you can kind of see on the left, the final animation, and on the right, that customizable game. And those will kind of run. Yes. So then a lot of time to work on these projects. And that's something that I'm even going through as I learn, giving students more and more time to explore projects. So then they can do a lot of things on their own. They can extend the projects, they can make adaptations for feedback that they get or changes that they want to make. And then you can see the one on the right is actually pretty cool. The student tied a lot of kind of artistic aspects into this one because he actually kind of created all of these pixelated images on their own. So especially the second semester, I saw students, instead of just kind of pulling in images, they were making their own. They were trying to maybe find a really specific image and then like take out and make it transparent so they could use it in their game. It really adapted in ways instead of just going the easiest path. They really kind of took what they wanted the game to make and they're like, I have an idea and I want to kind of roll with it. So they made all these pixelated images on their own, which is awesome, and had them go in the direction that they wanted to go so then it would make sense to them. And then actually I'm gonna have flip back to the previous slide because there were some questions on reflection. And really in this course also, I've tried to emphasize student reflection as something that helps guide students through being able to see what kind of problem solving they're using, what kind of collaboration they're using. So these are all actual questions that I had on a couple student reflections at the end of each unit. And even in addition to this, I have different ideas of ones that I want to add in. Maybe one about like, have I gotten feedback from other students or my teacher? Or even if we do have that end user, have I gotten feedback when I'm creating this product? We're really thinking about what kind of reflections am I having on my own? Am I talking to other people when I'm trying to figure these things out? How am I using problem solving? And really trying to enter these through all of the different units that we're doing and keep all of these ideas in mind. So using reflection both for me to see what students are doing and then students to also reflect and think, okay, did I problem solve during this unit? The next one, what ways did I problem solve during this unit, and kind of build on all of those ideas through the different units we work on. And I think that is all that I have for my summation of my course. So we can move on. I'm not sure what's next. Activity.
All right, I think we're turning it back over to Liesa. Yeah.
Yeah, so we're gonna just take a minute or 2 or 10 and let everyone here kind of take some time to think through computer science in your own setting, whether it's just your classroom or if you're part of a large organization and you want to think about it as an organizational unit. So we're going to follow a design thinking process. If you're not familiar with design thinking, it's a great way to approach problem solving, and it's what we use in my middle school STEAM course. And it follows a pretty basic nonlinear path of empathizing, so thinking about who's involved and then defining the problem, ideating solutions, and then ultimately testing and iterating. And so we'll go through that process a little bit here. So on the Jamboard, if you click the link, and I will post it one more time in the chat just in case we've had any newcomers. If you flip over to the second page in the Jamboard, it says empathize. Who are the stakeholders? Who are the people impacted by implementing CS in your classroom? What I'd love for you to do is just add as many sticky notes as you can with different groups of people that would be impacted by implementing computer science or continuing to improve computer science education in your school or your classroom. So who would be involved? Who would be impacted? So on anyone you can think of. Good. Somebody said students. Absolutely. Students would definitely be impacted. Staff. I love that somebody wrote staff. I'm going to take the lead. Somebody wrote staff, and I'm going to be specific and write teachers. Thank you to whoever said staff. Good. Yes. Principals are involved for sure. Somebody put on their school board. Yes. School board is a big one involved in this conversation. Thank you to whoever. Future employers. There's a great one. This is why we do this. Great one. Administrators, parents. Good. The greater community. I love whoever was starting to think about the greater community, and I would love to see some of us add on to that greater community idea. Let's be more specific. Who out there in the greater community? Who else is involved? Who else is impacted if we implement computer science? There are paraprofessionals. We have school librarians. Families, great one. Local businesses could be involved. Oh, I didn't spell that right, but that's okay. Spelling doesn't matter. Oh, somebody else from businesses. Great minds. These are great. Let's try and get maybe 2 more onto this board of people that are possibly impacted by implementation of a computer science or a STEM program, either in your classroom or in your school. So we can get 2 more. Oh, developers. Great one. Let's get 1 more on there, and then we'll move on to what's next. Oh, I love it. The environment. Oh, brilliant. Yes. Environment, nature. All right. Fantastic. Great brainstorming. If we were in my middle school virtual classroom, I'd have everybody unmute and applaud, but we're not going to do that right now. And then if you toggle over now to the next one, we're going to continue in our process. And now we're going to get into defining the problem. What is it that when we think about implementing a computer science program, sometimes one of the struggles that schools have is that everybody has an idea. And sometimes those ideas align and sometimes they diverge. So just take a couple of minutes and add on the post-it notes. What do you want to accomplish with CS in your school, in your classroom? Either as you're growing the program or starting the program, or even just starting to think about learning about CS. What would you want to accomplish? This one's trickier, so it might move a little bit slower. Cool. Good starts. So a basic understanding. Students experience and learn from failure. What else do we want to accomplish with computer science in our classrooms or schools? Introduction to programming language, learning other subjects while learning computer science. Sustainability. getting students comfortable with different programs and technologies. I'm gonna moving things around. These are good. Coding has rules and students can't just click away. Yes, coding and programming is very different from sort of sitting around and playing video games. One of the things that teaching computer science has taught me is the difference between consumption and creation. So students often struggle when they get into our classrooms, our computer science classrooms, because they think it's going to feel like playing video games, but that's a consumptive process, a passive process. And when they get into our rooms and we're teaching computer science, suddenly we're asking them to create, and that has rules. And you can't just click away and expect it to work out. This is great. I'm going to move us on to our last slide here. If you have ideas on either one of these slide brainstorms, feel free to come on back. So the last thing, this is where we ideate. And if you're already implementing computer science or STEAM in your classroom, I'm expecting some really good, crazy ideas. But I want you to add on some Post-it notes as many crazy ideas for how to add computer science to your classroom. And Jen and Edyn and I will be chiming in because maybe we can come up with some resources you haven't thought about. But the crazier, the better. Ways to get computer science into your classroom. Post-it notes, go. And I would love some feedback. How loud is this printer behind me? Do you need me to mute? Are we okay?
Yeah, it's not too bad.
No, it's fine.
Okay.
It's perfect for this presentation.
We're 3D printing the team names here for our Gen Cyber conference. When students learn CS as they're learning to read. Oh, what a great idea. Reading code, learning how to type and program in Python really gets at that reading. If you have a school or a classroom where you have reading goals and you want to improve kids' reading, programming in Python it's an amazing way to get kids reading. What
There's
other
even
crazy?
a whole bunch of books that you can use that instead of maybe in your elementary classrooms you might have a read aloud hour, and you could just choose to read something like Ara the Engineer or How to Build a Sandcastle, so that they're getting a little computer science content during some of that read aloud time.
End users in projects. That's bringing in actual people who are going to use, or that the kids can design for. If they can build it, they can use it. Oh, that's a great idea.
If they can build it, they can use it. I don't know if anybody, I've seen or I've heard some teachers talk about how they kind of have some maker stations in their room, but there's just a space in the room where students can go that has some of those materials Lisa was talking about earlier, the pipe cleaners and the markers and the construction paper and things like that.
Show a variety of people that are not involved, if not in person, in videos. Oh, that's great. Like bringing in community members. Partnerships with community organizations. Oftentimes you can find local businesses that would act as end users for kiddos to work on computer science or engineering projects. If you're looking for funding ideas, if you're looking for resources, the NSA, the National Security Agency, and the National Science Foundation, NSF, they have lots of materials. They have lots of grant funding. Those are great places to look for if you're looking for a place to start. talking about wind energy. There's a lot of computer science activities where they can work on programming, and then they can also pair that with engineering and design and building. That's a great idea.
I also love that. I mean, I think a lot of students these days are interested in climate and environmental justice and thinking along those lines. And so that's a nice way to tap into student interest.
This has been some really great brainstorming, everyone. There's a lot of suggestions on here of resources, places to start, places to look at. I've tossed in there Scratch and Raspberry Pi. Those are great ways to get kiddos starting to program with very little uptake. And Scratch is free, so there's almost no investment. Raspberry Pi, you can get a classroom set of devices for fairly inexpensive. One of the biggest hurdles with a lot of this technology is getting the adults in the room, you and me, familiar enough with the technology so that we feel like we could guide students. One of the things I'd encourage you as you're looking at all of these different opportunities, from wind energy to Pirate to Raspberry Pi, is that we're no longer in an educational universe where the teachers have to be complete masters of the content before facilitating student learning. One of the things I've learned in my classroom, in my STEAM classroom, is that it's really okay if I know as much as the kids, maybe even less when we start on a project. The open-ended learning, the self-directed learning will pull us all together along the way, and that it's a lot of fun when they ask questions that I don't know the answer to. So if you're looking at all these resources and thinking, gulp, I don't know that I could do this, it's really okay. You can learn it together.
I think that's probably a good segue into our next section of the presentation. So we just wanted to share some of the lessons. We thought lessons learned about what we're doing at Hermantown and trying to build these courses and make connections across them. And then we also realized, we're still figuring out how to do this. This is the building the plane while we're flying it sort of piece. So I would invite Liesa and Edyn to share some things. I'll just start with one piece there, this idea of recruiting. So in middle school, every 5th, 6th, 7th, and 8th grade students, they have 4 grades in middle school. All of them take a rotation each year in the middle school STEAM class. And then when they get to the high school, they have, as Edyn was mentioning, her course as a half-year elective. And then there's another longer whole year elective course that they can take. So how do we get students from that point where they're really having a lot of fun in middle school STEAM to say, oh, well, now you should take that computer science course in the high school if you want to keep learning about it. Liesa, Edyn, I don't know what else either of you would like to share from the slides here.
I'll jump in. A couple of things that I'm still learning is that I don't have to have. So a little background that might be helpful context here is for 12 years I taught high school mathematics, pretty traditional curriculum-based lessons and worksheets and activities. And then towards the end of that phase of my career, snack break. No, it's okay. Towards the end of that phase of my career, I started to pull in these STEAM concepts and help develop an actual STEAM design thinking and innovation course in the high school. And what I learned is that when I started to plan less and leave it flexible and wait to see where the projects and the students would go, I started to see from the kiddos much higher engagement, much higher levels of interest, and actually a lot more authentic learning. So I had to let go, and the lesson I'm still learning is I have to let go of the notion that I'm going to be able to know what's going to happen in the 45 minutes that I have them from bell to bell, and instead be able to say, like, well, we'll get started here and then I'll see where they go. And then we'll figure out what we're going to do next when we do next. It's that sort of that idea of just the next 500 feet. That's a big lesson that I've been learning. Something else we're learning too is that by planning STEAM curriculum or CS curriculum with this sort of open-ended, low floor, high ceiling approach, we're able to differentiate and accommodate every kid in the building. So I'm one of the only classes at Hermantown Middle School where every student that attends Hermantown Middle School can come to the STEAM classroom with everybody else and can start their learning with everyone else and can continue to drive their projects forward. And they'll all go someplace different. But every single kid, regardless of their learning needs, regardless of any accommodations or IEPs, they can all find a place in the STEAM classroom to get started, and they can all do work and learn and grow their skills. So those are two big lessons, or a couple of big lessons that I'm still learning.
And then for me, especially being in the first year of trying to develop the class that I'm teaching, the Exploring Data and Computing, I'm continuing, I think one of my biggest things is trying to get collaboration this year and how huge that is in computer science and design thinking. So really emphasizing that collaboration aspect, trying to get students in a classroom to get prompted feedback from others, but then kind of unprompted, going around talking to other students and how to best do that. So that's something that I kind of learned a little bit how to do it, but I'm definitely still learning how to implement it and how that benefits students in the classroom. And even outside of the CS course that I teach, how I can incorporate these ideas into my math classroom, because I only teach that one CS course, and then all the other hours in the day I'm teaching math. So really how to implement these ideas of design thinking, project-based learning, how to maybe tie in some of these CS ideas into my 8th grade and my 9th grade classroom. So those things that I'm still kind of going through, and the reflections of students are huge, and the reflections that I'm doing are kind of huge to get to that point of what's working and what's not. And especially even when we were going through the Jamboard of how to get CS into more classrooms, I was kind of thinking about my math classrooms of like, okay, what could I do? What kind of things to tie in? And continually going through it in that way.
So we're definitely not done. We just got out of a brainstorming session last week where we were thinking about, what are we doing at the elementary, middle, and high school levels? What concepts and practices from computer science and computational thinking are we using at each of those levels and emphasizing? And how can we make better connections across them? So we've started on that process because to date, people have mostly been like, oh, this is my class, this is what I do here, without yet thinking more deliberately about what comes before and what comes after. So hopefully by the end of the summer, we're going to have a much better defined scope and sequence for student learning, and then continue to focus on that recruiting part of getting students into high school elective courses. So those are some of our next big steps in terms of the computer science and STEAM pathways at Hermantown. I think the next part here, we were thinking breakout rooms, but we have a smaller group and maybe we want to just stay in the main room together. Okay. So I would welcome folks if you want to turn your videos on, unmute, now is the time to do it, but thought that you all, and I see Nathan shared in the chat some things that he's working on, might like to share about like what you're doing or what you're thinking about doing, or maybe you have questions for Liesa and Edyn about the courses that they have been working on creating and what's in them, or need more ideas on how do you just integrate computer science across different discipline areas. So would welcome you sharing during this time. Yeah, Nate, I don't know if you want to start us off and share more about what you're doing at your school.
So what I'm talking about was a few years ago, I was part of an out of school program, like summer program. And we had app clubs. So some of it was computer science, some of it was just learning how about the tablets and different apps to use. And like one of the projects we did was we went to the garden, took photos of the garden, and they made a presentation of what went on in the garden. So each of those sessions There wasn't like, it was one session at a time, so they got to choose whether or not to attend the next one. And I didn't have any trouble recruiting a variety of students because they know me from doing other things like playing tag.
I think that's an important point. Oh, I'm sorry. Go ahead, Darcy.
I just wanted to say good afternoon. That's it. Oh, I jumped into the wrong room. I'm so sorry.
That's okay. Everyone's welcome here, even for 2 minutes.
I recognize Edyn. So hi, Edyn.
Hi.
I totally just thought I jumped into my room, so I apologize for any, you can tell I'm nervous, obviously. I'm jumping into the wrong rooms. So sorry, guys.
No worries, no worries.
I would say you're at the right place.
Good call.
I see, James, I see your comment. I'm just soaking in the conversations and ideas. We've come to the right place because we're full of ideas. You currently don't have a CS program, but it's not unreasonable to think it will not develop later. I'm curious, are you a classroom teacher or an administrator? What's your role?
So I'm a 5th grade math and science teacher.
Oh, fantastic.
Yeah. So
You're at
we don't have a dedicated computer science, but the children have their own devices. And we do participate in Starbase. And so they do get that week-long immersion at Starbase to get them a flavor and ideas about moving forward with it. So up in the upper middle school grades, and they start getting a little bit more involved with the computers, but not in a computer science sort of way. I do know they do coding upstairs, but probably not to the extent that is being discussed here.
So you're in a perfect position if you ever wanted to explore changing things up in your classroom with computer science and STEAM like stuff. There's lots of great resources, especially for 5th grade. 5th grade I've taught 5th grade all the way through 12th grade computer science and STEAM, and I find that the 5th graders are they're like sponges. They love it. They are eager for more of it, and yeah, it's been my favorite age to work with computer science.
Nice. Okay, like I said, I'm just soaking it in right now. So
Yeah.
I'm gonna say one thing that is a nice place to get started, and I didn't think about adding it to our resource list, but I'll get it on the slides, is Hour of Code. So if you think that you have, or even a day that you've got a sub in the classroom and that you can't be there, Hour of Code has a whole bunch of activities, and you can filter by subject area, filter by grade band, filter by whether or not you have devices, or if you have to do something without devices that day. So there's a whole bunch of things that you can do in one lesson with students, or a couple of lessons with students. So it's a nice place to get going.
An Hour of Code is another one of those resources I've found where I don't have to know how to do any of it. All I have to know how to do is provide the link to the kiddos and an expectation of what I expect them to be doing with their time. You know, here's the link, and I expect you to spend the next 45 minutes exploring and trying cool activities. And then I just wander around the room and watch and see what they learn. And then I'm learning like, oh, that's cool, we could do more of that or whatnot. So Hour of Code is great for anyone who doesn't want to sit through like 2 weeks long of learn how to code PD. If you just want to have something to start up with in a classroom.
well, that's right up my alley right there.
Yeah.
Okay,
Yeah, just give the kids the link, tell them they've got 45 minutes, and you expect them to look around, see what they will just run with it. They'll have a blast, and you can just sip your coffee and watch.
So Nate, are you thinking about the out of school activities and how you can move into doing maybe some more things in the classroom now too, or
Yeah,
a more robust out of school program?
Yeah, because I'm not at the out of school program, so I'm focusing on the graduate studies right now. And my business some too. Just trying to get back in, but for now, focused on my business and the studies.
Yep,
And yeah, I used Hour of Code too.
you did. Okay. There's some other out of school programs, Girls Who Code, Black Girls Code, and I feel like I'm missing one or two, but I know Hermantown had a Girls Who Code club this year. They have a lot of preset resources that like parents can run, even if they don't have computer science background, but teachers can also do it too. So those are two additional ones. And I don't know if people do any work with like Boy Scouts and Girl Scouts, but they all have tech badges these days that are tied to computer science. So even in the out of school space, there's a lot you can do. And Boys and Girls Clubs, if anybody works with Boys and Girls Clubs, they also have computer science curriculum designed for their club spaces. So lots of connections, even in the out of school space too.
I had that in 4-H in the 1990s when I was part of that.
Yeah. 4-H does a lot of, there's a lot of 4-H robotics programs in the state too. They do the first Lego League robotics and that kind of thing.
At the time so that was the biggest out of school program in the country, educational. But I worked for the biggest in Brainerd, which was through the school district.
Sure. Jessica, I just wanted to check in with you. You're welcome to drop something in the chat or unmute if you have questions or anything that you would like to share about what you all are doing at your school.
I was just having a conversation with one of my school board members not that long ago about how do we change the things that we're doing in our schools, get kids more engaged in what we're doing and make it sustainable for later in life. Like, we can't guarantee that technology is always going to be here. And I feel like if we don't teach our kids some of the, foundations of like how to do renewable energy, how do we get around if we don't have a car, we don't have gas, or there's not a bus available, things like that. And how do we promote like more innovative thinking around those? Like, how do we do that as a school district? So it was just something I had been thinking about. And I did tell one of my school board members and she was going to look into it further, but that's where we're at as far as I know.
That's awesome. That's a start. I find that school board members can be kind of sometimes that like external poke to get things going in the district, and they can also be the champion and making sure that like funding is allocated and things along those lines. I think that came up in our stakeholder brainstorming earlier, so good deal. Well, I maybe wanted to just run through some of the resources that we had brainstormed for you all so you could think about whether or not they might be useful in your context. So Liesa was mentioning the Scratch programming language. That's one that she uses in the middle school STEAM class. It actually is used in Hermantown Elementary with the upper grades as well. The lower grades use something called Scratch Junior, which is more of an app that works on an iPad. And it has like fewer buttons and controls, so a little bit easier for the younger students to use. But Scratch is a great entry-level programming language, and there's a couple of really good curricula that are already out there that have lessons that are really easy to pick up and use. So the Scratch Creative Computing Guide, and then Google has this program called Computer Science First, or CS First. That one is really nice because there's some options where students can pick their path if they want to do something that's more artistic and creative, if they want to do storytelling, if they want to do a game, but they're all learning the same kind of computer science concepts. And then Bootstrap World. Edyn, do you want to talk a little bit about what Bootstrap is and the Exploring Computer Science course?
Yeah, so I did a PD that was Bootstrap algebra, but it was really kind of an intro to one of the other coding languages that came up on one of the Jamboards, Pirate. So I think Pirate is kind of a semi-related to Python and kind of has some aspects that are similar in that way. But we use Pirate for the code that you saw before the before each of the animation and the game is what we used. And we did that through kind of the curriculum that was Bootstrap Algebra. So it has a lot of really strong math connections, like working with a coordinate plane and adding to get it to move more to the right, or subtracting from the Y to move it, get it to move down. And then I think Bootstrap is really based around, even outside of math and computer science, try to getting the ideas of coding and data science into more classrooms. So I know there's also a data science PD that I want to take, because I want to think about data science more in that aspect too. But overall, just a lot of really good intros with that Pirate language of line code. I can't remember, there was something. And then overall getting it more classes, and then even just kind of doing some unplugged activities, breaking down some thinking and how code works on some different sheets and how functions work and different things like that. But they have some different programs. I know they have a physics one as well for that area, but they have a few different programs that I still am kind of digging into and figuring out more about.
In the Exploring Computer Science class, you use some of their units in your course, right?
Yeah, the game we developed in that way, and then we kind of adapted the animation through their curriculum and pulling things from there. So both the game and the animation, I'm pulling parts from Bootstrap for those.
And if you're looking for additional professional development this summer, Infosys Foundation has free summer online institute, and I think some of those ones are still available that you can sign up for. Some of them have started already too, but you can check that out. They run that every summer. Sometimes they have a winter institute, sometimes they have classes during the school year as well, but they generally offer it free or very low cost to teachers and school districts. So it's a good source for looking for professional development. The MDE is the Minnesota Department of Education computer science page there, where they do have the list of all of the, to date, the integrated standards in each of the subject areas. And this might be something that if you're trying to talk to your administrator about and saying, hey, we really need to start thinking about this, you can point them to the MDE page, but then the computer science specialist at MDE, Sarah Carter, she did a nice video overview of what the department is thinking and what their plans are and where they're going with it. And you can see that video if you go to the CS4 DLH, the Computer Science for Duluth project page there. And you can share that with anyone. So I think, oh, CodeApp is yours too, Edyn. We should have organized them, talked them a little better.
Yeah. CodeApp is, I use it for the data unit for my CS course, and I also implemented it into my math classroom when we were doing kind of creating data visuals and doing like box plots and different things like that. Overall, that's the part of just really getting them comfortable with working with some different programs and how they work and how they can create all of these different graphs or data points to be able to make conclusions and things like that. And then I also linked that sample data sets. They have a wide range of some different topics related to the data sets to pull from. So if anybody's in any different subject areas, that could be an interesting one to look into about with that data aspect.
I think we talked about Hour of Code and then some of those out of school programs. Lisa, do you want to talk through the resources you just added? And if anybody has other things that you would like us to add, just feel free to drop them in the chat and we'll get them added to the slide here.
Yeah, we're adding tons and tons of resources, and the truth is that we've just pulled together things that we know there are a billion zillion resources out there, and that it can be really overwhelming. And what I've found about resources personally is that it doesn't matter how many times somebody tells me about it, until I get my hands on it and start to tinker with it, that I personally don't really see it until I get my hands on. So my encouragement to those of you out there who are seeing all these resources and thinking either you're feeling overwhelmed or you just don't know how to get started, even if you have the resources, you know, just dig in and start trying some of these things. So a couple of things that I've put on there, these are ones that for somebody who taught math for years, but never was into computer science or computer programming and really was kind of afraid to start teaching it. These are some ones that I found were really helpful places to start and self-teach. So Raspberry Pi is a huge web bank of different kinds of coding activities. And they have block coding, which is easy to get kids started and teachers, but then they also have Intro to Python, which is script-based coding. But then they also have physical devices to get started with that basic electronics piece. And it's also low startup. So you could get their Raspberry Pi 400 for like $70. And that's essentially a full-on, fully functional computer that just needs to be plugged into a monitor. It doesn't have a hard drive. It just has an SD card, and it runs Linux. So it's free and open source. So you could get, you can get a set of these that kids can start right into coding and programming fairly straightforward for not that expensive. The next resource I put on there, this is ISTE or ISTE, and these are standards for learning. This is a resource that I go back to for developing my STEAM curriculum. It's a really brief but in-depth set of ideal standards for 21st century learning. So it covers everything from digital citizenship to being able to design and solve problems, to collecting data, to evaluating sources. I really have structured my entire curriculum around the ISTE standards because I think they're simple. Kids can understand them, parents can understand them. You show this to any school board and they will always say, yes, absolutely, this is what we want our kids to learn. And yet a lot of this stuff is either missing from or sort of obliquely mentioned in other curriculum content standards. So I highly recommend checking out the ISTE standards. They've got great ideas. The next resource is Common Sense Media. Common Sense Media has a lot of free materials.
Got 1 minute left.
Okay, 1 minute left. Common Sense Media, lots of free lessons and stuff related to digital citizenship. So not necessarily computer programming, but helping kids navigate an online world. And then the last one there, the Turing Tumble, that's just a physical game. There's also a computer version, but it's a great thing for younger kids to learn about computer programming through puzzles.
Awesome. Thank you, Liesa and Edyn, for presenting and sharing about the classes at Hermantown. And thank you all for being here and the great questions you asked and resources you shared too. No, we didn't include our contact information. I'll drop my email in the chat. Folks are welcome to reach out to me with questions and I can connect you with Liesa and Edyn as you want, or if you guys want to share your email in the chat, you're welcome to do that too. So, thank you all for being here today.